It's because I've been teaching 18 years. I don't need a warm-up. I'm ready to go. Unit 6. Conic, I want to say this. Conic Circles. Unit 6, Conic Circles. ELT is up here on the board. It's kind of hard to see. Let's zoom in a little bit. You can see that the first learning target says, I can find the center and radius of a circle from the equation written in standard form, or find the equation given the center of radius. So you need to be able to graph it, and then from the graph you need to be able to tell me the equation. I've told you that it's easy, so watch and pay attention. Alright, copy both of those equations down. These are the equations for circles. If I take the x value and square it and the y value and square it and set it equal to r squared, what do you think r stands for?
Radius.
The radius. Write that down. R stands for the radius. And I square the radius, then I get the equation of a circle. What do you think HK stands for? If you had to take a wild guess, what do you think HK stands for? What's important on a circle? Alright, let's talk about the definition of a circle. What's the definition of a circle? A set of points.
Equal, like around the diameter?
No.
I mean around
If I were to go down to the game field and I were to say, okay, it's soccer season and I got to draw a circle, right? Don't y'all start off in a circle, right? And I have to draw this circle and it's 15 meters in diameter or whatever. How would I draw a circle, a large circle out there on the game field, on the grass?
put a rope and just go all the way around.
I would put a stake down where?
In the middle.
No.
The middle of the circle.
We have a name for the middle of a circle. Starts with a C.
Center.
Circumspect.
Center.
We're going to have to do a take 2 on this.
Is it center?
The center of the circle. No, you didn't. You said middle. Holy mackerel. I didn't hear it. I didn't hear anybody saying center, center, center. The only important part of a circle is the center. There's no other part of a circle. Write center on your paper and circle it and star it. If you were to go down to the game field and have to spray paint a circle, you would put a stake in the center of the circle with a rope measured out to your what?
Radius.
Not diameter, it would be radius. And then what would you do?
Just go around the circle.
Right? You'd walk. If there's the center, you'd walk in that circle. The definition, write this down, seeing as how we don't know the definition of a circle. The definition of a circle is the set of all points equal distant from the center. The set of all points equal distant from the center. Right? It has to be equal distance. If it's not equal distance, then we get an ellipse. You know, or something else. We don't get a circle. So back to my discovery learning. What do you think HK stands for? The center of the circle. Write that down. Not negative H and negative K. We said that R was the radius, and we're saying that the center of the circle is at HK. So if there's no HK like there is in this equation, where do you think the center is at?
The middle.
The center is at 0, 0. We have a name for 0, 0, and it's not middle.
Origin.
The origin. The middle. Where do you think the center is when it looks like this?
H-E-K.
Very good. Write that down. HK. HK is the center of the circle. What does R stand for? The radius. How many radius does a circle have?
So will H and K always be?
I'll say radii because that's the plural of radius. How many radii does a circle have? That's 4, and that's it?
360.
You got a
It's
question?
not a very good circle, but if this was the circle,
However many as it wants.
which we have a name for that,
Infinite.
infinitely many radii, right? Each one of these is equidistant. What does equidistant mean?
It's a circle.
Right? They're all the same.
Will H and K always be equal to 0, 0?
Are all circles center at 0, 0?
No.
No. Can I move it around?
Yes.
Yes. Look at the formula though. If this is HK, what are we doing in the formula with H and K? We're going to do the opposite and the opposite. Okay? We'll do the opposite and we'll do the opposite. Okay? Alright. I'm going to change gears a little bit. Don't stop the video. Alright, let me have your attention. Hit the lights over there. Watch and learn. I can do this on Desmos 10 times faster than I can do it drawing up on the board, and the circles will be a lot better. So watch, copy down what you feel is necessary in order for you to understand the material. Alright? The most basic example, if this will load, there we go. Alright, so x squared plus y squared is equal to 1. Alright, so here is the most basic example that I can think of. Alright, where's the center of the circle?
0, 0.
Well, it's at 0, 0 right here. Okay, what is the radius of the circle?
1.
It's 1 because r squared, right? Let's see if this will work. R squared was equal to 1. And if r squared equals 1, I square root both sides, r equals plus or minus 1. It's going to work eventually. Is the light green? Yes. Come on. There we go. See? So r equals plus or minus 1, but can a radius equal a negative value?
No.
Can the radius equal negative 1?
No.
No. So r just equals 1. It always is positive. Write that down. All radii are positive. In geometry, we don't have negative distances. Even if I drove my car backwards from the school to my house, that would still be a positive number. Okay? Just because I go backwards doesn't mean that it's positive. So what is this distance from here to here? Well, it's 1. What is this distance? It's 1. This distance is 1 and this distance is 1. Why? Because the definition of a circle is the set of all points equal distant from the center. Alright, so now let's start having some fun with this. Okay? What do you want to do first? Do you want to manipulate the radius or do you want to manipulate the center?
The radius.
Alright, so what do you think? Well, let me put a 1 in here and turn it off. What do you think's going to happen if I put a 9 right
The
there?
radius is going to be 9.
Wrong.
Bigger.
Boom. Come on, Rocket.
The radius will be
Look at your formula.
The radius will be 9.
I can't see it, man.
No, it won't. Take another guess. If I change this to a 9 right there, then what do you think the radius is going to be? Why?
Because you square it.
Look at the formula.
R squared.
Look at that.
9 equal to r squared. You got to take the square root.
So what if you have one without square root?
You don't. The formula is r squared. So that number, whatever is that number right there, we take the square root of it, and 3 is our radius. You better be writing this down, guys. This is easy.
What if it wants to equal 8 or something?
What if this value wants to be 8?
Yeah.
Then the radius is the square root of 8, 2 root 2. It's a decimal, but it's 2 root 2. Okay?
Are we going to have any of that?
Sure. Sure. What if it was 100? What's the radius now?
10.
And this isn't difficult, but you have to understand that whatever's out there, the radius is the square root of that value. All right, so can this value, what if I change this to -4?
It'd be 2.
Plus or minus 2.
Whoa, it'd be imaginary.
Good guess.
It'd be 2.
It'd be 2.
Can I graph with a radius and I square that radius and get -4? No, there's no graph of that. That number, write it down. That number out there can never be negative. Ever.
But what's the square root?
What's the square root of -4? Somebody already said it's an imaginary number. This doesn't work.
Imaginary
So that number has to be positive. What happens if I change it to positive?
2.
What's the radius now? Oh, watch this. What if I change it to C and I add a slider and I make it go between -10 and 10? What's going to happen?
What do you mean between negative
It's gonna
10
get bigger, bro.
Oh,
Whoa.
that's cool.
What is going
It's
on?
hard.
Why isn't it showing up now?
Oh, because it's negative and it's too small for the graph to pick it up.
Uh-huh. Well, what if I speed it up?
Yeah. Oh yeah. Fast.
Like that?
Fast.
All right, so
Slow.
what if I pause it and I change this from 0 to 400?
Don't never go
It'll go up all the way up to 20.
Very good. Let me zoom out.
There you go, Rocky.
There you go. I can slow it down, right? Why is it moving?
Once it gets big, you
told it to.
Because I've created a slider in C. R squared is now going between 0 and 400. And so the radii are somewhere between 0 and 20. Square root of 400 is, what's that? Radii. It's the plural of radius. I'm pretty sure on that.
Right, yeah.
All right. So are we good with this number? Manipulating this number?
We're going to do all that C slider stuff.
No. I'm just showing you some cool stuff about Desmos. All right, let's get rid of this. Maybe.
Oh.
How do I get rid of this? There we go. All right, so x, well, let's go ahead and say parentheses, x plus 1. Bring it outside the parentheses squared. Plus, always plus in the middle. If it's not plus in the middle, it's no longer a circle. You might want to write that down. Y minus 2 squared, right there, equal to 1. And we're going to turn it off. All right, so now what are we manipulating?
The center is on the
Are we
graph.
manipulating the radii, the radius, sorry, or are we manipulating the center? The center of the circle. All right? For $64,000, used to be a game show, the $64,000 question. What is the center of this circle?
-1, 2.
Correct. -1, +2 is the center of the circle. Why do we have to do opposite?
Square.
Because of the formula. The formula says x minus h and y minus k. Those plus squared equals r squared. We have to do the opposite and the opposite in order to find the center. The center is simply at -1, +2. -1, +2. So the center of the circle is going to be right there. What's the radius going to be?
1.
How do you know that?
That'll be R squared.
Because we took the square root of 1 and we got 1. We actually get plus or minus 1, but we disregard the negative value. So we go to the right 1, we go up 1, we go left 1, and we go down 1. Right? Notice, I'm not going to draw a diamond. Right? This is how I'm showing you how to draw it by hand. I'm going to round these corners off so that I get a nice circle. I might have to use the big dot theorem. That's pretty technical. I'm not supposed to learn that until next year.
I'll write it down.
But the big dot theorem. Very technical.
Big dot theorem.
All right, so let's turn it on. What'd I do?
You just did
You
that right.
You did.
Not 1, 2.
Oh, I messed up. What did I do wrong?
Didn't graph it right.
Yeah, you didn't
graph
You put it to the 2.
I didn't put the center in the right spot.
No, you sure did. I was about to say something, but I thought you was.
Did you have it at .5?
Well,
Say something.
what messed me up in my defense was that it's going by 2s. There we go.
Wait, but then how is that radius on?
See, -1, 2. See the 2 right there?
Yeah.
I only went up 1. I should have went up 2.
Evil.
But I thought
You're
it was-
confused.
I don't know.
I thought the
I don't know what
radius
you're
was
doing.
The radius is 1. So what is the radius? The radius is from the center to the edge of the circle. So from here to here, it's 1. It's 2 blocks. That's what threw me off. So 1, 1, 1, 1. Okay, let's do another example. This is not difficult. Okay?
So what will
Everybody else stop talking. Seriously, guys, we're on camera. Now hush. All right, I'm going to change this to 16. I'm going to change this to -4. I'm going to change this to +3. All right, first question. Let's go. Hold on. Let's go back and read the learning target. I can find the center and radius of a circle from the equation written in standard form, or find the equation given the center and radius. Okay? So here we are. All right. Where do you think the center is of this circle?
4 -3?
4, -3. Let's see if I can get this right. 4, -3. So the center of the circle is right there. What is the radius?
4.
Sure?
Yes.
Not 16?
No.
Not -4? No. The radius is 4. Very good. So watch. I would count up 1, 2, 3, 4. I would go to the right. 1, 2, 3, 4. I would go to the left. 1, 2, 3, 4. I'd go down. 1, 2, 3, 4. Right? From the center, I would get those 4 dots. And when I graph it, that's what it looks like. There's the center, right where my cursor is, and there's my circle. Let's change it to projector mode. There we go. That's a little easier to see, yes?
Yes.
Alright. So, I say again, I do opposite. My center is at 4, -3. I take the square root of 16.
It's not big enough, so there's only 1 there. I think it's just off to the side.
Oh, that wasn't what I wanted to do.
Refresh it.
Put the undo.
Go back.
There's
What
no
did I
button.
undo button?
Undo, right
At
above
the
your-
top.
Oh, good job. Leave this page. No, stay
I
on
said
this page.
that. I said that first.
All right, but why is it
I
the
think
16
because that
showing
spot's
up?
not big enough, so it just threw the 6 off to the side.
It's there.
Yeah.
This is not equal to
Like,
1.
click on the thing.
Like if you click on the thing, I think it'll move over
Where?
and like try to.
Oh, there we go. It just gives you more of the graph, I guess. All right. So, questions.
Nope.
All right.
Can I come up?
Yes. It'll be the world's longest video.
Whenever it was zoomed out from the center to this right here,
Mm-hmm.
it was 8 points, not 4.
That was because they were 8, 5.5.
They were half points.
Yeah,
What's half of 8?
4.
What's the radius?
So it's 5, 2.
4. The radius is 4.
Okay.
You see? So it was 8 half points. What's 8
Hey, Brian, give me a shout out.
half points is 4. Right? 8 50-cent pieces is 4.
Shout out, Chris Hill.
All right.
You need a shout out.
All right, so now I want you to write, quiet please. Let me zoom in so that it's easy here. All right, write the equation of this circle.
It's not true.
It looks like a square turned sideways. Really good.
Write the equation of that circle. At least try. Write the equation of that circle. We're going backwards. I'm giving you the graph. What I want you to do is go backwards and write the equation. Please don't talk.
We were comparing answers.
Looks like I'm going to get about half done today and about half done tomorrow, which is fine.
Oh, the video?
No, on the learning targets. I can graph a circle written in standard form. I can complete the square. See, I'm not going to get a chance to talk about 3 and 4 today. So I'll talk about 3 and 4 tomorrow. No big deal.
Are you gonna edit the video?
All right, here we go. Start off with x minus h squared equals plus y minus k squared equals r squared. Right? That's the formula. That's the formula anytime that the center is not at the origin. If the center is at the origin, it's just x squared and y squared. Okay? So you have to find the center. What are the coordinates of the center? Negative 1, 0. So that's your h and that's your k, and they have to go into that formula. But when I take negative 1 and I do the opposite of it, what does this become? X plus 1 squared. If you didn't put plus 1, it's wrong. Because you got to do the opposite. Okay? What always goes in the middle? Plus. All right, what about this one? When I take 0 and I put it right there, what do I get? I just get y squared. Yes, technically I get y plus 0, but is there any reason to put y plus 0?
Nope.
Nope. All right, what about r? What is r in this case? The radius is 2. The radius is 2. The radius is 2. The radius is 2. If the radius is 2, then what do I put out here?
4.
I put the square of 2, which is 4. Okay, if I put 2 out there, it's wrong. Questions? Any questions? All right, let's do one more of those. Does everybody have this written down? Does anybody have a question how I got that equation? Would I mark it wrong if you put y plus 0?
No.
No, I wouldn't, but that's just extra. I'm telling you, they wouldn't do that in Illuminate. All right, so I'm going to see if I can do a non-hand drawn one.
What this one?
I deleted it. Give me just a second. All right, here we go. Directions. We'll say, write the equation of the circle given the graph. Try it now at your desk.
Oh, that's easy.
The cursor is not at the center. Let me try to put it on the center. Right there is the center. This is your chance to... Alright, what do you think? Chris Hill, what do you got?
I know it's -4, -3.
X minus 4?
No, that's 3.
X minus 3 squared plus, what would the y be? Quiet.
-4.
Why minus 4 if it's up?
Opposite.
You gotta do the opposite. Very good. Equals what?
9.
If this is the center, right, I gotta count, right? How far is that?
9.
That's 3, sorry. And then the square of 3 is 9. Okay, give me a thumbs up if you got that right here. Thumbs up. Okay, right here, right here. Good job. All right, questions? Any questions? All right, I say again, what looks different about this problem?
Equal to
Yeah, it's
15.
two 80s.
Well, there's no parentheses, and it's very difficult to see H and K as is. We say that this is written in conic form, right? We want it written in standard form so that we can easily see H and K. Luckily, one of the things that we learned in Unit 5 will help us rewrite it from conic form into standard form. Watch and learn. X squared minus 2x plus y equals 15. I'm going to say x squared minus 2x. I just dropped that down. And I'm going to say plus 2. Plus y squared, over here 15, plus 2. Now why in the world did I do plus 2?
Opposite.
Completing the square.
Yay! Outstanding! I completed the square. This divided in half is -1. -1 squared is not 2.
It's 1. It's 1.
It's 1.
Yeah, I was like,
And he still got it right.
That's why I threw me
It's 1. 1. My fault. I should have known that because what are we going to get over here? We're going to get a nice perfect square.
Yeah,
Duh.
19.
So I got x minus 1 squared, right? This factors into this. I got plus y squared, and then over here I got 16. Now, does it look like it's written in standard form?
Yes, sir.
Yes, it does. Why did I have to add 1 to both sides?
That's
Yeah, I think that.
If I add 1 over here, and I don't add 1 over here, then it's not going to be equal.
Yeah.
Okay, you have to add 1 to both sides. What is the center of this circle? Positive 1, what?
0.
0. What is the radius of this circle?
4.
Not 16, 4. Correct. I know.
You gave me the look.
All right. Was that easy?
Yeah.
I told you I could, if I had a little bit more time, if we were on 90-minute periods, I'd be done with this whole unit. All right, you try this one. Quiet, please. You try this one. Shh. You try this one. You try this one, please.
Let's get it.
Is that camera still on?
Yeah.
I'm taping this one here. I probably won't use it though, even though Mock gave me my right answer
Well, I'm just gonna wait till you cut off the ring.
Shout out,
because I made a mistake.
shout out to
He
Brady.
just made a mistake.
Shout out to Big Bird.
When a man wears dress shoes and they're this color, what is it called?
I know.
Brown.
Oxford.
Grass.
Come on, fashion
Professor.
horse down there. What is it called? Starts with a C.
Church.
Center.
Church shoes.
Avery.
You have to have a belt that matches.
What's
Cognac.
Your belt always matches. You got brown shoes, you have a brown belt.
Connect.
It's Conic.
Cardio band. Cardio band. I could be wrong. I mean, there may be another name for it, but cardio band is what it was.
Why are you wearing dress shoes today?
I have a high-level meeting after school today.
Oh, I see.
High level. For
High
what?
level.
I get everything.
Not at liberty to say.
Yeah.
He's good. He's getting recruited by colleges.
Scroll.
Turn your cell phones off, guys. I'm still.
Speaking of my meeting, the person that's in charge of the meeting texted me.
The head of the CIA just texted you.
Yes, it's almost that high.
President is
Oh, man.
All right. What do you have to do twice?
Complete square.
Complete the square. Watch. Watch and learn.
Twice.
X squared plus 4x plus what?
2.
Half of that's 2. 2 squared is 4. So over here I put plus 4. What about this one? Y squared minus 6y
9.
plus 9 plus 9. That and that cancel out.
4.
So I got x plus 2 squared plus y minus 3 squared is equal to 4. This factors into that. That number is always half of that number. This factors into this. This is always half of that number. We completed the square 2 times. Alright, finish it out for me, Godby. Where is the center of the circle? Outstanding. What is the radius? Outstanding. Could you graph it?
Yes.
If I ask you to graph it, where's -2, +3? -2, +3 is right here. I go down 2, to the right 2, up 1, 2, left 1, 2, and I draw a nice circle. That's it. Tic-tac-toe. We'll do more of those tomorrow.